You probably have played games where you roll 2 dice, possibly maybe even more recently. We're all, maybe board games are coming back with what's going on, but when you roll 2 dice, you often add the 2 numbers together that you roll. Think for a second before, it's okay to pause the video for a minute, but think about what do you think are, well, first we should start with what are all the possible sums you could get when you roll 2 dice. Let's agree on that first. You could get a 1. No, you can't. Not for a sum. You could get a 1 on each dice, on each die, but that would be 2. You could get 3. You could get all the way up to getting it's called boxcars, 6 and 6. 1s are called snake eyes, so you get a sum of 2, all the way up to 12, right? You could get any sum all the way up to 12. Of those possible sums, which do you think is most likely, or do you think they're all equally likely? That's the thing I wanted you to think about for a second. If we consider, let's say we had 1 red die and 1, let's just imagine that's a green die. We can look at a tree diagram. So I could get a 1, 2, 3, 4, 5, or a 6 on the red die. But then if I get a 1 on the red die, I could still get a 1, 2, 3, 4, 5, or a 6 on the green die. Same if I rolled a 2 on the red die, I still have 6 possible outcomes for the green die. And I wouldn't recommend necessarily making this tree diagram, because I'm going to show you an easier way to look at this in just a minute. But if we did make the tree diagram and we started looking at the sample space, if I get a 1 and a 1, the sum would be 2. 1 and a 2 would give me a sum of 3. I think you see the pattern here. In blue, I'm listing all the sums we would get, or not would get, could get, all the sums that are possible. Five and a 1 would be 6. 6 and a 1 is 7. 6 and 2 is 8. All the way up to a sum of 12 if we had 2 6s. Now, there are 36 possible outcomes. Even though, there's different ways to roll a 4, but rolling a 1 on the red and a 3 on the green is a different roll than rolling a 3 on the red and a 1 on the green. Same sum, but a different possible outcome. And so, if we look at it that way, these are all out of 36. These probabilities. So the denominator in all these probabilities will be 36, but the numerator would be all the favorable outcomes, like how many ways are there to roll a 2. You don't have to look too hard to see that there's only one way, only if I get a 1 on the red and a 1 on the green. There's only a 1/36 probability of rolling a sum of 2. But a sum of 3 could happen with a 1-2 or a 2-1. 1 red, 2 green, or 2 red, 1 green. So there's a 2/36. And I know that simplifies, but just for the sake of comparing these different probabilities, we won't simplify them all the way down in this case. A 4, you could get a 1 and a 3, a 3 and a 1, or a 2 and a 2. So there's 3 ways to get a 4. 5, there's 1, 2, 3, 4. 4 ways to get a 5. 6, you could get a 1 and a 5, a 2 and a 4, 3 and a 3, 4 and a 2, and a 5 and a 1. So that's 5 ways to get a 6. 7, 1 and a 6, 2 and a 5, 3 and a 4, 4 and a 3, 5 and a 2, 6 and a 1. There's 6 ways to get a 7. An 8, you can get a 2 and a 6, 3 and a 5, a 4 and a 4, 5 and a 3, 6 and a 2. What was that? 5. That's weird. The pattern changed. It was going up every time, and now it's going down. 9, you could get 3, 6, 4, 5, 5, 4, 6, 3. So there's 4 ways. It's going to go down now all the way to 1/36 for rolling a 12, because the only way to get a 12 is a 6 and a 6. it's even easier to see these probabilities when instead of a table, instead of a tree diagram, you make a table in an array format. I'll show you what I mean. These are, by the way, theoretical probabilities. If we were in class, I would have you roll dice with a partner and compare the theoretical probabilities to the probabilities you get from your experiment. And then we put all of the class's data together, you would see that they come out pretty close to these theoretical probabilities, for that same reason we talked about last week, that if you get enough experimental data, it eventually matches the theoretical. Okay, if we make an array, we put all the possible numbers we could roll on the red die, 1, 2, 3, 4, 5, or 6, and all the possible numbers we could roll on the green die, 1, 2, 3, 4, 5, or 6. Then we can make these intersections the sum. Like if I roll a 1 on both die, I get a sum of 2. If I roll a 2 on the red and a 1 on the green, I get a 3. 3 on the red and 1 on the green, I get a 4. You see how this works. 1 on the red, 2 on the green, that's a 3. 2 on both die, that's a 4. This you should fill in on your notes, because I believe I put this table on your notes. It's also these problems with rolling 2 dice come up a lot, and so it's good to know how to make this array and see all the possibilities. Even if I didn't give you the table to fill in, it wouldn't be too hard to make one of these. I'll prove that in a second. I would recommend doing it with more room than I'm going to do right now, but here's what I mean. Just anywhere I could quickly remind myself, just by making a quick look. I'm not going to do it, but you get the idea, right? It's not that hard to make this table. And the nice thing about the table is some patterns are even easier to see. Here's our most probable sum. There are 6 ways of the 6 times 6, or 36 possible outcomes to get a 7. You see there's only 1, 2, just like there's only 1, 12. There are these the sums appear diagonally in this table. It makes them easier to count.